Let's continue the view of data. The term we are going to see is mapping, which is defined as a key for providing data independence. So we can define the term data independence is the capacity to change the schema at one level without changing the schema at the next higher level. There are two types of data independence over there. One is logical data independence. The second type is physical data independence. So let's see the definition for logical data independence. So this logical data independence will be provided by the external or conceptual mapping. And we can define the logical data independence as the ability to modify the conceptual schema without changing the external views and the application programs. So changing the conceptual schema may be changes to conceptual schema may be necessary whenever the logical structure of the database changes due to the changed objectives. For example, if we can go on adding the data items to the schema, adding some price field of the part to the part table, adding project table to the supplier parts database, etc. So coming to the definition of logical data independence, whenever there is a change or modification at the conceptual level without affecting the user level or the external level, that is the higher level, it is known as logical data independence. For example, the name field in the conceptual view is stored as first name, middle name and last name, whereas in internal view it remains to be as a single name field. So coming to the second type of mapping, that is data independence, is physical data independence. This is provided by the conceptual or internal mapping. So it's defined as the ability to modify the internal or physical schema without changing the next higher level, that is conceptual schema or the view level schema and the application programs. So changes to physical schema may be necessary to improve the performance of the database or data retrieval or data updation. So achieving the logical data independence is more difficult than the physical data independence because application programs heavily rely on the logical structure of the data they access. So let us come on to the definition of physical data independence. Whenever the changes are made at the internal level without affecting the above layers, it is known as physical data independence. For example, the location of the database, if changed from C drive to D drive, will not affect the conceptual view or the external view, as the commands are independent of the location of the database. So let's see the difference between logical data independence and physical data independence. So logical data independence is concerned with the structure of the data or changing the data definition part. Physical data independence is concerned with the storage of the data. Logical data independence is very difficult as the retrieving of data are heavily dependent on the logical structure of data. Coming on to the physical data independence, it is easy to retrieve the data. And in logical data independence, the application program need not to be changed if new fields are added or deleted from the database. In case of physical data independence, the physical database is concerned with the change of the storage device. And from the logical data independence, it is concerned with the conceptual schema, and physical data independence is concerned with the internal schema. And these are the references used for preparing the presentation.